In this module we learn about confined space. The details about the hazards in confined space and the control measure will be demonstrated in next parts. In this module we learn what is the definition of confined space. Confined space can be defined as is large enough and so configured that an employee can enter bodily and perform work. Has limited or restricted means of entry or exit. Is not designed for continuous human occupancy. So that is the definition of confined space. We will learn more about confined space in next parts. In this part, some examples of confined space will be given. The examples of confined space are following: tanks, manholes, boilers, furnaces, sewers, silos, hoppers, vaults, pipes, trenches, tunnels, ducts, bins, pits. These are all above examples of confined space. We will learn health hazards in confined space in next part. In this part, we will discuss potential hazards in confined spaces. The potential hazards in confined space are following: oxygen deficiency. If oxygen level is lower than 19.5% in atmosphere, then this condition is called oxygen deficiency. Low oxygen concentrations can include giddiness, mental confusion, loss of judgment, loss of coordination, weakness, nausea, fainting, loss of consciousness, and death. Oxygen enrichment. If oxygen level is above 23.5% in atmosphere, then this condition is called oxygen enrichment. Excessively high or enriched levels of oxygen above normal concentration in fresh air can dramatically promote or accelerate combustion and other chemical processes. Combustibles. The most common combustible gas found in confined spaces is methane, CH4, which can be easily produced by microbial decomposition of materials like sewage and rotting vegetation. Methane is lighter than air, and tends to rise. Apart from methane, hydrogen, acetylene, propane, gasoline fumes are also present, which are considered combustibles. Toxic materials. The most common toxic chemicals in confined space fatalities are hydrogen sulfide and carbon monoxide. Hydrogen sulfide, H2S, gas is commonly found in sewers and can be instantly fatal at higher levels in confined spaces. Disturbing sewage sludge can release hydrogen sulfide gas. Electrical and mechanical hazards are also present in confined spaces, which can lead to severe accident. These all above hazards need to be controlled by suitable control measures. In this part, we will discuss about oxygen-deficient atmospheres. An oxygen-deficient atmosphere, which can cause asphyxiation, is defined by the Occupational Safety and Health Administration, OSHA, as one containing less than 19.5% oxygen by volume. When oxygen concentration is 19.5% in atmosphere, then this is considered as minimum acceptable oxygen level. When oxygen concentration is 15 to 19%, then it causes decreased ability to work, impaired coordination. When oxygen concentration is 12 to 14%, then it causes increased respiration, poor judgment. When oxygen concentration is 10 to 12%, then it causes increased respiration, poor judgment, lips become blue due to lack of oxygen. When oxygen concentration is 8 to 10%, then it causes mental failure, fainting, nausea, unconsciousness, vomiting. When oxygen concentration is 6 to 8% and if any person stays there is 8 minutes or more, then it can be fatal. When oxygen concentration is 4 to 6% and if any person stays there, then the person can go to coma within 40 seconds. So this is to ensure the oxygen level of confined space before entering to the confined space. In next part we will learn the hazards of oxygen-enriched atmospheres. In this part we will discuss about oxygen-enriched atmospheres. When oxygen level is above 23.5%, then this is considered as oxygen-enriched atmospheres. It causes flammable and combustible materials to burn violently when ignited, like hair, clothing, materials, oil-soaked clothing and materials. It is recommended that never use pure oxygen to ventilate to avoid oxygen-enriched atmosphere. It is recommended that never store or place compressed tanks in a confined space. So oxygen-enriched atmosphere is dangerous like oxygen-deficient atmosphere. In next part we will discuss about flammable atmospheres in confined space. In this part we will discuss about flammable atmospheres. There are two critical factors for flammable atmospheres. One is oxygen content in the air and presence of a flammable gas, or vapor, dust, visibility of 5 feet or less. Proper air-gas mixture can lead to explosion. Typical ignition sources are following: sparking or electric tool, welding, cutting operations which is considered as hot work, smoking inside confined space. Flammable atmospheres can cause devastating accidents. In next part we will learn about toxic atmospheres in confined space. In this part we will discuss about toxic atmospheres. The most common toxic gases found in confined spaces are carbon monoxide, CO, and hydrogen sulfide, H2S. These gases are usually measured by means of substance-specific electrochemical toxic gas sensors. Toxic atmospheres are created in confined space due to the following reasons. Toxic gases can be created due to products stored in a confined space because of following reasons. Toxic gases can be released when cleaning. Materials absorbed into walls of confined space can create toxic gases. Decomposition of materials in the confined space can create toxic gases. Toxic gases can be created because of work performed in a confined space like welding, cutting, brazing, soldering. Also, toxic gases can be created in confined space due to painting, scraping, sanding, degreasing. Sealing, bonding, melting inside confined space can also create toxic gases. The toxic gases must be detected before entering to confined space, and suitable control measure must be taken to avoid any accident due to release of toxic gases. In next part we will discuss in details about two toxic gases, hydrogen sulfide and carbon monoxide. In this part we will discuss about most common toxic gas found in confined space, which is hydrogen sulfide. Hydrogen sulfide can be present inside confined space because of decomposition of materials, human waste. The odor of hydrogen sulfide is similar to rotten egg at low concentrations, but possibly no warning at high concentrations for hydrogen sulfide. Now we will discuss about ppm, which means parts per million of hydrogen sulfide and its effect on human health. If concentration of hydrogen sulfide reaches 10 ppm or below, then this is considered as permissible exposure level for 8 hours duration. If concentration of hydrogen sulfide reaches 50 to 100 ppm, then any person can experience mild irritation in eyes, throat if this person continuously stays in that atmosphere for 1 hour. If concentration of hydrogen sulfide reaches 200 to 300 ppm, then any person can experience significant irritation in body if this person is continuously exposed in that atmosphere for 1 hour. If concentration of hydrogen sulfide reaches 500 to 700 ppm, then it can lead to loss of consciousness, or it can cause death. If this person is continuously exposed in that atmosphere for half hour to 1 hour. If concentration of hydrogen sulfide reaches greater than 1000 ppm, then it can lead to loss of consciousness, or it can cause death. If this person is continuously exposed in that atmosphere for more than 1 minute. So presence of hydrogen sulfide must be detected by gas detector before entering to confined space, and suitable control measures must be taken to avoid any accident from it. In this part we will discuss about another most common toxic gas found in confined space, which is carbon monoxide. Carbon monoxide, CO, is an odorless, colorless gas formed by the incomplete combustion of fuels. When people are exposed to carbon monoxide gas, the carbon monoxide molecules will displace the oxygen in their bodies and lead to poisoning. Now we will discuss about ppm, which means parts per million of carbon monoxide and its effect on human health. If concentration of carbon monoxide reaches 35 ppm or below, then this is considered as permissible exposure level for 8 hours duration. If concentration of carbon monoxide reaches 200 ppm, then any person can experience slight headache, discomfort if this person continuously stays in that atmosphere for 3 hours. If concentration of carbon monoxide reaches 600 ppm, then any person can experience headache, discomfort if this person is continuously exposed in that atmosphere for 1 hour. If concentration of carbon monoxide reaches 1000 to 2000 ppm, then it can lead to confusion, nausea, headaches, if the person is continuously exposed in that atmosphere for 2 hours. If concentration of carbon monoxide reaches 2000 to 2500 ppm, then it can lead to loss of consciousness or it can cause death. If any person is continuously exposed in that atmosphere for more than 30 minutes. So presence of carbon monoxide must be detected by gas detector before entering to confined space, and suitable control measures must be taken to avoid any accident from it. In this part we will discuss about another most common hazard in confined space, and that is engulfment hazards. In certain confined space environments, workers can be at risk of potential engulfment. This refers to any situation in which an individual is trapped by bulk materials, such as grain, or liquids. The most serious consequence of engulfment is asphyxiation, followed by potential crushing. The engulfment hazards are caused due to following reasons. Loose, granular materials like grain, sand, coal stored in bins and hoppers, which can cause engulfment hazard inside confined space. Crusting and bridging below a worker can cause engulfment hazard. Flooding inside confined space can also lead to engulfment hazard inside confined space. Water or sewage flow inside confined space also can create engulfment hazard. So risk assessment must be done to detect potential sources of engulfment hazards inside confined space before entering to confined space, and suitable control measures must be taken to avoid any accident from it. In this part we will discuss about other hazards in confined space like noise, slick, wet surfaces and falling objects. First we will discuss about noise hazard inside confined space. Any sound is amplified due to acoustics within the space, and it can create high noise. It may lead to damaged hearing, affect communication. Next hazard is slick, wet surfaces. Slick, wet surfaces can lead to slips and falls, and also it increased chance of electric shock. Falling objects is one of the hazard inside confined space because topside openings expose workers inside confined space to falling objects. So risk assessment must be done to detect potential sources of above hazard inside confined space before entering to it, and suitable control measures must be taken to avoid any accident from it. There are many toxic gases. Flammable gases can be present into the confined space, and also there is a chance of oxygen deficiency and oxygen concentration inside confined space. So testing of the atmosphere must be done prior to enter to confined space. Verify presence of safe work atmosphere. Test all areas of a confined space. Top, middle and bottom. It should be always keep in mind that methane is lighter than air, carbon monoxide is the same as air, and hydrogen sulfide is heavier than air, and also about oxygen deficiency and oxygen-enriched atmosphere. During testing of the atmosphere, the following must be considered. Check for oxygen content. At least 19.5% and less than 23.5%. Check for combustibles. Less than 10% of the lower explosive limit. Check for toxic gases. Most commonly carbon monoxide, permissible exposure limit less than 35 ppm. Or any other hazardous materials as determined by the use of the space. Gas hazards are unpredictable and confined spaces are dangerous, making it very important for confined space workers to continuously monitor gas levels with a direct reading portable gas monitor. Direct reading monitors not only tell workers whether the atmosphere in a confined space is safe, but also how safe. So testing of the atmosphere must be done continuously while working inside confined space. In this part we will discuss about the ventilation inside the confined space. So, what is the proper ventilation for a confined space? According to the AIHA, American Industrial Hygiene Association, an acceptable practice is 20 complete air changes per hour, or 1 every 3 minutes for a confined space. Ventilation of a space will also vary depending on the type of material that is being ventilated from the space. Air intake in a safe location to draw fresh air only. Continuous ventilation whenever possible. Retest the confined space before entry. If ventilation is not sufficient in confined space, then following process should be done. Use of mechanical ventilation like fans, air horns. This is to be ensured that ventilate at the rate of at least 20 volumes per hour, and larger spaces require more ventilation. Make sure air supply is not contaminated and ventilation air supply must be from fresh air and air must be uncontaminated, that means free from with flammables, toxins substances. In next part we will discuss about purging. In this part we will discuss about the purging inside the confined space. Purging involves removing contaminants inside the confined space by displacement with air to achieve acceptable atmospheric levels. After the contaminants have been removed, purged, the confined space may be ventilated. Ventilation means the continuous provision of fresh air into the confined space by mechanical means to maintain acceptable atmospheric levels. In the next part we will discuss about inerting and flushing techniques. In this part we will discuss about the inerting and flushing. Inerting is a special form of purging and ventilating. Inerting involves purging oxygen from a confined space using an inert gas, such as nitrogen, carbon dioxide or argon, to remove the hazard of fire or explosion. The concentration of oxygen is decreased to below the level that can support combustion. Before entering a vessel, confined space, remove all residual materials, pump or drain, as completely as possible. Flush the vessel, confined space with water or an appropriate cleaning solution and follow with a final water flush. We will discuss more about confined space safety in next parts. In this part we will discuss what must be done before entering to the confined space. First we need to isolate the confined space from all hazards before entering to the confined space. All the valves need to be closed where valves are present, example, double block and bleed, blank flange. All the pressures inside confined space need to be depressurized, all the fluid need to be drained inside confined space and proper ventilation need to be ensured inside confined space. All the electrical sources to be isolated inside confined space, rotating, reciprocating parts to be isolated. The isolation of hazardous energy sources to be ensured by lockout, tagout. Residue left in confined spaces such as empty tanks and containers can cause a buildup of toxic or explosive gases. Clean residue from the confined space. That is the end of this part. We will discuss more about confined space safety in next part. In this part we will discuss about importance of toolbox talk which is required before entering to the confined space. Studies have shown that the toolbox talks can reduce the occurrences of safety incidents by up to 82% when they are carried out daily instead of monthly. The meetings are most effective when carried out just before the scheduled job begins. Entire crew, attendants, entry supervisor, must attend the toolbox talk. Review of hazards of entry and work to be done during toolbox talk. Review of personal protective equipment must be done during toolbox talk. Review of procedure for contacting rescue and availability of rescue team must be ensured during toolbox talk. It is to be ensured that permit to work is completed during toolbox talk. But this toolbox talk does not qualify any person to work in a confined space but will alert you to the dangers so that any person does not take chances. Special training and briefings is essential. We should always keep in mind that, do not attempt to enter any confined space unless you have been properly trained. There are many toxic gases. Flammable gases can be present into the confined space and also there is a chance of oxygen deficiency and oxygen concentration inside confined space. So testing of the atmosphere must be done prior to enter to confined space. Verify presence of safe work atmosphere. Test all areas of a confined space. Top, middle and bottom. It should be always keep in mind that methane is lighter than air, carbon monoxide is the same as air and hydrogen sulfide is heavier than air, and also about oxygen deficiency and oxygen-enriched atmosphere. During testing of the atmosphere, the following must be considered. Check for oxygen content, at least 19.5% and less than 23.5%. Check for combustibles, less than 10% of the lower explosive limit. Check for toxic gases. Most commonly carbon monoxide, permissible exposure limit less than 35 ppm. Or any other hazardous materials as determined by the use of the space. Gas hazards are unpredictable and confined spaces are dangerous, making it very important for confined space workers to continuously monitor gas levels with a direct reading portable gas monitor. Direct reading monitors not only tell workers whether the atmosphere in a confined space is safe, but also how safe. So testing of the atmosphere must be done continuously while working inside confined space. Inside confined space, atmosphere testing shall be performed prior to every entry when the space is vacant. After a 10-minute ventilation period, if ventilation is necessary. At least hourly for permit-required confined spaces. More frequently, if conditions or suspicions warrant. Any time a limit is exceeded, no matter what the reason, all personnel shall immediately exit the space, and no others shall enter until atmospheric conditions are returned to safe levels. That is the end of this part. We will discuss more about confined space safety in next parts. In this part we will discuss what must be done during working inside confined space. An attendant shall be posted near the entrance for the duration of the work. He shall be in constant communication with the entrance while the job is in progress. All entrants shall sign the sign-in log when entering the space and sign out when exiting. The attendant shall maintain the permit and sign-in log for the duration of the work. That is the end of this part. We will discuss more about confined space safety in next parts. In this part we will discuss what must be done when work inside confined space is completed. When work inside confined space is completed, then the following steps must be followed. Remove all personnel, tools, and debris from the space. Sign off the log. Close the space. Cancel the permit. Review the job with the host employer, hazards, problems, other employers, etc. That is the end of this part. We will discuss more about confined space safety in next parts. In this part we will discuss about roles and responsibilities of confined space personnel. There are basically 4 types of job position for confined space, and those are following. Authorized entrant, attendant, entry supervisor, rescue service member. We will discuss the above job positions in details in next parts. In this part we will discuss about entrant responsibilities. The job description of confined space entrant is following. To assure that the space has been adequately ventilated, isolated, emptied, or otherwise made safe for entry. To immediately exit a space, without question, upon word of the attendant, no matter what the reason. To follow all safety rules and procedures that apply to the job. To be familiar with the work to be performed and the procedures that apply to the job. To use the appropriate personal protective equipment whenever necessary. We will discuss the job description of confined space attendant in next part. In this part we will discuss about role of confined space attendant. The role of confined space attendant is following. An individual stationed outside one or more permit spaces who monitors the authorized entrance and performs all attendance duties assigned in the employer's permit space program. Confined space attendant must have knowledge of the hazards of the space. Confined space attendant must aware of possible behavioral effects of hazard exposure in authorized entrance. Confined space attendant must continuously maintain an accurate count of authorized entrance. The attendant must never enter a confined space, even for rescue, unless specifically trained and authorized to do so. He or she is equipped for safe entry, and he or she is relieved by another authorized and trained attendant stationed outside. In the next part we will discuss about confined space entry supervisor. In this part we will discuss about role of confined space rescue service member. Confined space rescue teams are trained to calculate response and rescue times, practice the necessary rescue procedures, and execute rescues when an emergency occurs. Duties for specific team members include: evaluate the site before work commences. Create rescue and contingency plans. The job description of confined space entry supervisor is following. To assure adequate protection is provided to the entrance by verifying adequate lockout, tagu, and that all hazards are securely isolated. In the next part we will discuss about how confined space rescue operation is performed. In this part we will discuss about role of confined space entry supervisor. The job description of confined space entry supervisor is following. To assure adequate protection is provided to the entrance by verifying adequate lockout, tagu, and that all hazards are securely isolated. To support the attendant's authority in controlling access to a confined space. To verify that all personnel have exited prior to closing the space. To assure that all personnel involved are aware of the hazards associated with the space. To assure that rescue services are available prior to entry. In the next part we will discuss about responsibilities of rescue service member. In this part we will discuss about confined space rescue operation. Confined space rescue is a subset of technical rescue operations that involves the rescue and recovery of victims trapped in a confined space or in a place only accessible through confined spaces, such as underground vaults, storage silos, storage tanks, or sewers. Confined spaces are often narrow and constricting, preventing easy access by rescuers, making confined space rescues technically challenging. The spaces are usually unlit or poorly lit, requiring a light source to be provided. Confined spaces may contain hazardous materials in liquid or gas form, and oxygen may be limited. These hazards can be fatal as they create a limited window of time in which to perform a rescue. After 4 minutes without oxygen, a person will usually suffer asphyxia, causing brain damage or death. The urgent need to rescue someone from a confined space often leads to ill-prepared rescue attempts. 2/3 of all deaths occurring in confined spaces are attributed to persons attempting to rescue someone else. Confined space rescue categories. Self-rescue. A person may recognize a critical condition or symptoms of exposure, and exit the space by themselves. Alternatively, an entry monitor outside the space may recognize a new hazard and have people leave the space before they are affected. This is the preferred rescue method, as confined space hazards can quickly incapacitate or kill. A person can almost always exit a confined space much faster than waiting to be rescued. Non-entry rescue. A non-entry rescue involves attempting to extricate an incapacitated person without having anyone else enter the confined space. Entry rescue. This is a last resort option, as having more personnel enter an area that has already incapacitated one or more persons places the rescuer at considerable risk. Entry rescues must be carefully planned and executed to avoid creating more victims in need of rescue. Rescuers need to be aware of their surroundings and must re-evaluate their plans immediately if there is any change in the conditions of the confined space. In the event of an entry rescue, standby rescuers are recommended in the event that the initial entry rescuers encounter trouble. In the next part we will discuss about confined space rescue equipment. In this part we will discuss about confined space rescue equipment. Due to the unique nature of confined space rescues, there is specialized equipment necessary to perform a safe and successful rescue. One of the initial pieces of equipment employed in a confined space is a method of ventilation to disperse collected hazardous gases and introduce fresh air into the environment. A wristlet is often the first item used to actually perform the rescue, as opposed to the ventilator, which is used to prepare the environment for a rescue. A wristlet is a cloth strap that is used to cinch tightly around the wrist or ankle of an incapacitated person. Once the strap is looped around a hand or foot, its attached rope is pulled by rescuers, tightening around the arm or leg and pulling the victim out of the confined space. In the event that an entry rescue must be performed, rescue personnel will wear protective clothing appropriate for the situation. This may include a self-contained breathing apparatus, SCBA, protective headgear and the use of explosion-proof lighting, to prevent igniting any gases. The rescuer may also wear a full-body harness with an attached safety line, especially if a vertical descent is required. To assist in vertical descents, a mechanical winch and tripod may be set up over the access point, if the bottom of the confined space is more than 5 feet from the entrance. The rescuers may also carry monitoring equipment by which they can ascertain the quality of the air in the environment. Even if the air quality reading does not indicate any hazardous conditions, it is still recommended that rescuers wear self-contained breathing apparatus. In the next part we will discuss about necessary personal protective equipment for confined space work. In this part we will discuss about importance of personal protective equipment inside confined space. Personal protective equipment, PPE, is essential for workers who enter confined spaces, such as tanks, pipes, silos, or sewers. Confined spaces pose various hazards, such as oxygen deficiency, toxic gases, fire, explosion, or entrapment. Choosing the right PPE for confined spaces depends on several factors, such as the nature of the work, the type of hazards, and the regulations. This is important. To select the right PPE for confined spaces is to adhere to the safety procedures for using and maintaining the PPE. This includes reading and following the manufacturer's instructions, inspecting the PPE before and after each use, cleaning and storing it properly, replacing or repairing it if it is worn out or damaged, reporting any problems or incidents related to the PPE to your supervisor or employer, training and educating yourself and your co-workers on the proper use of the PPE, and complying with the relevant standards and regulations for the PPE. It is essential to choose the right PPE for confined spaces in order to protect yourself from potential hazards and carry out your work effectively. By following these steps, you can ensure that you are safe while working. Common types of personal protective equipment for confined spaces include respiratory protection, such as air purifying respirators or self-contained breathing apparatuses, eye and face protection, such as goggles or face shields, head protection, such as helmets or hard hats, hearing protection, such as earplugs or earmuffs, hand and arm protection, such as gloves or gauntlets, foot and leg protection, such as boots or leggings, body protection, such as coveralls or aprons, and fall protection, such as harnesses or lifelines. It should be always keep in mind that PPE should be the last resort to protect against risks. Thank you for attending the lecture. Work safely today and every day.